everybody, and welcome to another episode of The Proud Skill Worker. Today we have Kevin York and Henry Gilliland from ES&E with us. Gentlemen, thank you so much for being on the podcast today.
Glad to be here.
So I want to take a couple of minutes and jump into your background, your history. Kevin, let's start with you so we don't awkwardly walk all over each other.
Not a problem. So I went to East Carolina University, majored in industrial distribution and logistics. During that time, I worked for an industrial supply company throughout those years. And then once I graduated college, I started to work for electric supply and equipment for ES&E. And been with them for 17 years now. 17. Okay. I apologize. See, there we are stepping on each other anyways. Henry?
Yeah. So I went to North Carolina State University, got a degree in computer engineering and electrical engineering. Right out of college, I ended up working at a textiles mill as a plant engineer. And I think the best description for what I was doing there was like an apprentice millwright. I was doing everything: welding, machining, electrical stuff, the whole gamut. I was getting messy every day. So it was a lot of fun. After that, I went to work for an industrial recycling equipment manufacturer. So they make industrial shredders and sorting equipment that goes along with that. So I was a design engineer for those guys, and learned a lot there, had a lot of fun. After that, I went to work for an integration company, so designing electrical control panels and then programming them, and then actually going out on site to our customer and starting up the equipment, the whole gamut of engineering there. That was a pretty demanding job, to say the least. So, and we had our first kid, and I wanted to have a more, stable kind of job situation, work-life balance, less travel. So I ended up coming over to ES&E. So now I can, I still travel quite a bit with ES&E, but I'm home every night, and I still get to be involved with technical, the technical side of things that I love here. But yeah, been with ES&E about 5 years now. So yeah.
Okay. So 17, 5, 22 years with ES&E between the two of you guys, plus an additional, sounds like anywhere between 8 and 10 more years. So we're talking 30 years of industry knowledge at bare minimum, from the manufacturer to the installation to the engineering side. Is that fair between the two of you guys?
Yeah.
It's great. So for today's episode, guys, what we're going to do is we're going to deep dive a couple of things that I think are important that manufacturing technicians and technicians as a whole need to understand better what their responsibility is when it comes to these troubleshooting calls. So when an engineer shows up on site, you guys can provide us some insight for our employees and also for those watching, what they should have done already to speed up the troubleshooting process. I think you guys have a set of skills and experience that you can tell people, hey, before you make the phone call to your OEM or to ES&E, which we'll jump into a little bit about what you guys do as an organization here in a second. But I think it'll be really interesting for you guys to give people 4 or 5 steps that everybody should take before they call that OEM, before they get on that phone with that next level of resource, because I think you guys probably can troubleshoot 60% of things with 4 or 5 steps that people maybe just don't do. That's kind of the flow for today, just so everybody knows. It'll be a little different. This will be more of a troubleshooting tips and tricks episode, and less of a how do you succeed inside of the maintenance field. So Henry, Kevin, tell us a little bit about what ES&E does.
ES&E has been an industrial electrical distributor for 85 years, but we've grown and changed a lot over that time period. We've expanded our core products drastically and continue to do so. And we've added technical services and resources that help us provide the highest quality and highest value to our customers. Today, ES&E is a high-tech industrial automation solutions provider. We help our customers solve difficult problems on a regular basis.
It's great. So for the two of you, just getting into ES&E in the world, what drew you guys to the trades? I mean, I know you guys both have degrees in engineering. from one side to the other. Why take this into the trades? Why not take this behind a desk and draw schematics for the rest of your life and just live out the engineering world? I mean, why are you guys choosing to be on the floor?
Truthfully, I mean, I grew up kind of on a family farm, just very hands-on type applications, enjoy that. Not one to typically sit behind a desk all day. I like to be out, be involved in things. So it's just kind of what drew me kind of go down that path.
Yeah. So for me, I thought I did want to do sit behind the desk and be the design engineer. But I ended up in that textiles mill right out of college. I actually did an internship with those guys during my college years. That sort of drew me into industrial manufacturing and that hands-on type of role that Kevin's talking about. For instance, I didn't know what a PLC was when I graduated. If I had graduated from college with only university knowledge, I wouldn't have known what a PLC was. I wouldn't have even known what a relay was, because we didn't talk about that stuff. We talked about, embedded electronics, integrated circuits, that type of thing. And so I thought I wanted to be, sort of a digital designer and do that, behind the desk type design work. But I kind of fell in love with the automation world during my internship, went into that role, and yeah, it's a lot of fun. We see a lot of different stuff all the time. There's never a dull moment. We don't sit behind a desk almost ever. This is, rare for us. We're almost always out in front of machines solving problems. So all of those things is sort of, as a whole, is what drew me personally to the industrial world.
I love it. I think both of you guys hit on the big topic for people who find themselves in the trades, and also across all the industries, is people who want to fix things. They want to use their hands, and they want to be a part of a kind of an agile solution to things. As you guys talk about, ES&E is a solutions network. You guys solve problems. If problem X presents itself, the solution is, let's figure that out. So as engineers, when you guys get calls from these industries or the companies, or as technicians after you guys install an automation line, really whatever level you guys are getting called from, what are the first series of questions you guys tend to ask those companies or those people? I mean, what are the questions that come to mind when you go, okay, have you done these 3 or 4 things? What are those?
I think we kind of pulled, me and Henry were talking before a little bit. One of the first things that come to his mind is this a new problem? I mean, is this a ongoing issue that you're looking at, or something that's a totally new problem out of the blue? So that's kind of one of the first things we like to establish. Just that way, then we can look into, has something changed recently with the process or the machine, to kind of start narrowing down our focus a little bit.
Yeah, I agree. I think, how long has this machine been running is usually the first words out of my mouth, because that gives you sort of a split in the problems that you could run into. If it's a new install, we're looking at sort of new install issues. If it's been running for 20 years, then we probably aren't going to look at the programming, right? Because the program doesn't change itself. So that type of thing. And then we start digging deeper into, okay, well, now that we're narrowing down the types of issues that we might be running into, if it's an older piece of equipment, then the likelihood is high that we're going to be probably looking at a mechanical issue, because mechanical wear and tear happens more often. Those problems crop up more often than electrical issues. Now, you do see electrical fatigue as well, and we look into those things. But based on the type of symptoms that you see, you can usually split it up. Hey, is this mechanical, electrical? And then again, narrow down the list of possible issues even further.
Yeah, I think that's really smart. I mean, you guys brought it up. Like, how long has the machine been running? Oh, for 26 years until yesterday. Okay, well, whatever you did yesterday was the problem. So I think it's interesting to look at these machines, and people get probably a little creative on the floor with their troubleshooting at times, where they go, well, it's got to be this problem. Well, that doesn't make sense from a perspective of it's been running perfectly fine. So that question in itself, I think, would probably eliminate anywhere between half to 3/4 of all faults that technicians would chase down. Is how long has it been running, and what have you recently done to it that has changed? And then those two would pretty much lead you down your troubleshooting path, whether it's the new install or the mechanical failure side. So that's fascinating just to think about, because technicians change shifts and they manage through things, and it's just not something that's really on their mind. They come in at 6 a.m. and they're like, lines down, doesn't matter. But overnight we did X, Y, Z. Okay, now we know where to start with our troubleshoot. So super helpful there. That's cool. When you get into those questions, typically, are you seeing, and this might be more industry specific for you guys on the automation side, but are you seeing more mechanical failures out of maintenance, or are you seeing more new install failures from probably the install not going correctly?
I would say both. That's probably I don't know. I would say about 50-50. Yeah. I mean, it just, again, it depends on the machine and who we're working with that, points us in one direction or the other. But, again, with older equipment, especially really old equipment, it's going to be more likely in general to see mechanical failures than electrical failures. It's an interesting trend, I think, that we've been seeing over the past, say 10 years with equipment that's been installed within that sort of 10 to 15 year time frame, because the electrical side of things are just done differently now. There's that old axiom, they don't make things the way they used to. And there's a lot of truth to that, right? There's things like RoHS that prevent electronics manufacturers from putting lead in solder, and things just wear down quicker because of that. It's not a bad thing. It's just the way that it is. As electronic components get smaller, the leads get physically closer together. And so now, a piece of conductive contaminant that before, 50 years ago or 20 years ago might not have caused a short, well, maybe now it does, right? Mm-hmm. And so we're seeing electrical failures with newer equipment that are caused by things like that as well.
Yeah, it's one of the things in the past. I mean, some of the older stuff, like Henry was saying, you didn't have the environmental factors that some of these plants that they work in affect some of the newer components a lot faster than you saw in the past. And then on some of the component side of things are not repairable. So, I mean, it kind of, you just change the whole product out, and it's shrunk in size tremendously. The other thing, I mean, a lot of OEMs, everybody's looking at their panel space or layout, so they're putting things in there a lot tighter than they used to do. So that can generate more heat in a panel and cause some issues that way. So,
but it's also reduced cost, right? So, we might replace an entire component, whereas before we might have replaced a board or something, but I can replace that whole component for the same cost as before, right? So we're reducing the cost. And then also, as we're seeing these failures, these types of electrical contamination failures, manufacturers are putting in technology and protective measures, if you will, to prevent against those types of failures. So we're learning as we're going, and the technology is getting better. But it is what it is. We're learning as we go. So.
Yeah, I think when I hear you guys talking, one of the really cool things is, hey, technology is advancing. Here we go. We're moving forward. It's getting smaller. It's getting more difficult to troubleshoot. But what I think people sometimes forget, and what we often write out as, well, machines are going to take our jobs, or automation, all that stuff, is that as these components have gotten smaller and more advanced, we at times let our skilled technicians lag behind that instead of keeping them up to pace. So you guys are on the forefront of watching industries do these huge pivots to high-end, high manufacturing machines, but their maintenance team is used to something 50 years ago. So as you guys just described, you bring in a circuit board from, we'll call it 1970, that big, spacious, you can basically do whatever you want and solder on it. You're not going to damage anything else. And then you ask that same team to do maintenance on it from something done 5 years ago. They go, I can't work on this. Look at the technicality between this. And it brings into mind the need for this upskilling of people in the industry, not just new people coming into the industry, but even the people who have 15, 20 years of experience need to go, hey, the industry's changed a little bit, but it's changed in an educational standpoint, not in a how does a component work? We just made it smaller, so now we have to get a little better at it. And I think that's a really interesting dynamic that I think you guys probably see more than I do. But you watch these maintenance teams go from, being able to change out whole boards to changing out whole boards in this like small micro level, and it just makes things more difficult. And then, as you guys called out, industry things change. I mean, water intrusion is a thing across certain industries where they have to clean. Temperature becomes an issue across some industries, whether it's hot or cold or what you're doing. Just knowing the effect that all of those variables have on components that you guys know is, one, really good to learn, and two, a lot of life experience, I think, that you guys get over crash courses. That leads me to this question I have about, what do you think 3 to 5 things every multi-craft technician should always be doing to grow their career and to learn to troubleshoot more effectively? Because when I left the Marine Corps, the only troubleshooting technique they really taught us was half-life troubleshooting, and I don't know what it's called in the industry nowadays, but it was go halfway and tell me if it works. If it works there, the fault is between there and the front. If not, it's between there and the back. And I was like, that makes a lot of sense. But what's the evolution of troubleshooting that you guys have seen? 2 or 3 trends you guys think people should be buying into that they're just not?
You want to start?
Yeah. So just a couple of things that come to mind quickly. One of the kind of big thing that's been aided me in troubleshooting, other than, like you mentioned, the kind of the midpoint method or going to the center, is just your operators, your machine personnel that are running the machines on a day-to-day basis. Just finding a good one you can talk to and give you maybe some insight on what might be different if it is a new problem. What's changed? Have they changed components that they're feeding the machine, or raw materials? Because that obviously can affect things as well from that standpoint. So that's one good resource that's not to be overlooked out there. The other thing is kind of what tools are available to you from a diagnostic standpoint. What lights are on certain PLCs? What can I look at software-wise? Just familiarizing yourself with those tools and just using those to your advantage to aid you in the troubleshooting process.
Do you know, Kevin, of a good resource to go to in that PLC lighting community? Like you just mentioned, like indicator lights and those. Is there a centralized location, or is that going to be all OEM specific, most likely in a manual? Or Henry, your smile tells me it's not going to all be in one spot, and you're going to have to go look for it.
Well, maybe to answer that question for Kevin, I think for our customers, for us, mainly we want them to come to us for those types of things, right? So that's probably, the general answer that I would give. I think that different manufacturers have different levels of quality of documentation.
Yeah.
You think that's fair? And so, it just, it depends on the industry. But I think, one thing I was going to say too is as we advance in technology and as we're increasing the diagnostic indications that we're seeing, there's different tools for troubleshooting that are available now that weren't available before, that can help you solve problems more quickly. And using that technology, using the analytics, using the diagnostics that come from these smart sensors, understanding that is available now, and actually utilizing that data, utilizing that technology, I think will get you to a solution faster than it would have in the past. And if you are looking for that, and you're up against, someone who's been in the industry for 50 years or 40 years or something like that, they're not maybe looking at that, right? So you might get to a solution faster than them just because you're using the tools at hand that weren't available in the past. I don't know if that fully answered your question. But.
No, I think that's good. I also think, so two things, or one thing you guys both hit on that I think a lot of people miss is the value in this team troubleshooting idea. Henry, you called that out, like somebody who has a lot of experience, but maybe is not stepping into the new age of troubleshooting very easily. You guys, that's a tag team combination that's going to do a really, really good job troubleshooting all types of faults. And I think, Kevin, you even brought in this piece that I think gets overlooked a lot in the operators. So those operators spend anywhere between, 6 and 10 hours a day within arm's reach of that machine. They know, hey, when we changed the product that goes in, we turned the way that it goes in, we adjusted these small things, and it's their day-to-day job, so it gets communicated to them. That's not always communicated to the maintenance team. Like, hey, today we're taking product X and we're pivoting it to this angle because it goes, we need this product made. Well, if the maintenance team shows up and doesn't know you made that adjustment, they're troubleshooting something they know nothing about. So that operator, that maintainer, and then that seasoned mechanic, however that team is together, is a very valuable tool all at once. If each one of them tries to do it on their own, I think that they probably fail or come up short in keeping that line up and going. So I think you both brought up that piece, and I was always a big fan of that. More eyes, quicker troubleshooting, and move on from the problem. Now there's a line where you get too many people involved and some of you are just standing, and so you got to be delicate with it. But I think it's so valuable as you guys bring up your guys' own team and how you guys communicate with each other and the teams on the floor and these layers and layers into troubleshooting, that it's not the Wild West and you're not alone anymore. You can't do it all by yourself anymore on some of these machines. This is my favorite part of the show. So this is the part of the show where I turn it over to you guys, and I want to give both of you guys probably 3 to 5 minutes and say, if you could have every mechatronics or every automation specialist or every mechanic or electrician, everybody in the industry could hear these words, I want to give you guys about 3 to 5 minutes to get on a little soapbox and go, hey, stop doing this or do this more, or just something that you guys wish. And we all have them. I mean, let's be serious. We all have those moments where we all go to work on our own and we're like, man, I wish I could just tell everybody that. So what is your guys's? What's your guys's, your scream it from the mountaintop moment?
So I think I'd probably say 2 things for me that I would want every technician, engineer even to know or to do. I guess it's not even a knowledge thing. It's just do this. It's the first is, being able to understand proper installation of the equipment by reading the manual. Just read the manual. There's a lot of technical resources that are available from manufacturers, and 9 times out of 10, when there's a problem with especially a new installation, but a lot of different things can lead to this. You see issues that are there because someone didn't install it per the recommendations or per the requirements of the manufacturer. It's like trying to use a blender as a rock grinder. You're not using it according to the specifications, so it's not going to work the way you want it to work, right? So yeah, read the manual is one for me. It takes time to do that, and that that's read the manufacturing manual, but that's also look at the schematics for the piece of equipment that you're working on. So whether that be electrical or mechanical schematics, again, it takes time to do that. But when you do that, you really, I think, put yourself above, other people that are just honestly too lazy to do that. When you actually take the time to sit down and actually read the documentation, that takes you a huge step of the way towards getting where you need to be. And then the number 2 for me is when you make a change. So when you're troubleshooting and you make a change, troubleshooting, and the problem doesn't go away, put it back. Okay? Whatever change you made to try to fix the problem and it didn't fix the problem, put it back the way it was before, and let's start back at square one, because that wasn't the solution and all you're doing is compounding issues. Let's not compound trouble. So that would be my 2 big things that I would want everyone to know if I could only have 2 things. So yeah.
Yeah, and to Henry's point, I think definitely the reading the manual, or at least going to research what that fault code is, it can aid you tremendously in the first steps in understanding what a lot of these problems are, and really digging into the problem, not just let's change this part out and move on from it, to understand what's actually going on with a piece of equipment, so that you can prevent that failure in the future, or maybe it's a repeat issue that you're dealing with. You can solve that problem. from that standpoint. And one of the other ones, I mean, coming from starting at a pretty green into the field when I started, is just don't be afraid to ask for help. I mean, nobody understands everything of all pieces of it. So just try to find a couple people you can rely on to mentor you, and ask them early on in the process, not wait till the 9th or 10th hour when everybody's yelling or screaming at you to get that machine back up and running. The earlier you can get your resources involved, a lot of times the better they can help you.
Yeah, that's a really good one, Kevin. We often get calls on like Friday at 4:30, and they'll say, "Hey, I've been working on this all week," and we go, "Why did you just call me just now?"
Yeah,
we could have gotten to the solution before, but it's because the weekend's coming up and they don't want to be here over the weekend, right? And so they're putting it in our lap. But yeah, absolutely. Don't be afraid just because you're asking a question doesn't mean you're stupid. You know, just because you're asking a question and looking for more resources, it doesn't mean that you aren't capable. It just means that you need some help, and that's okay. So yeah, we ask our technical resources questions all the time.
Yeah, we each kind of have our own specialty here, and so we each kind of rely on each other and bounce things off of each other. So
I love it. I appreciate it, guys. I think that's probably some of the best honest, like on the floor life advice that we've gotten on this show in a while. The two pieces I want to add is as you mentioned, both Kevin and Henry, is if someone does come for you and ask for help, don't put them down. Don't shame them in those moments. So if you're the person who's acting as the resource, be the resource, give the information away. Don't make a big deal out about your knowledge versus their knowledge. I see it all the time where people are like, "Oh, you need my knowledge. Let me and they make a show out of telling someone the answer. Don't do that. Stops people from wanting to come to you. And the second one, I think it's great what you guys do. The manuals, the publications, sure, they're probably a boring read, but they tell you exactly what to do step by step. And it's pretty easy to go, this is where we missed. So Henry, I think that's a big one for people as they go, yeah, I know exactly what I'm doing. You skip step 6. Oh, I don't know what I'm doing. And so it's really good. Huge thank you to both of you guys for being on the show. For anybody who's watching the show, please take a couple minutes and Google ES&E. Definitely go to their YouTube channel. They have a lot of really great resources. At the early part of 2020 hit when all of that happened, ES&E made a huge pivot to go online and do technical resource classes that are available to all of you. Take some time, jump into their YouTube channel. You can learn anything you want on there from the automation team, from the mechatronics team. Anything you guys need, jump in there. And if you need them, reach out at ES&E. I know that the team here with both Kevin and Henry and Andy and Eric, everybody down there, it would be more than happy to help you guys out. Some really exciting news coming from the ES&E world with skill work. So we'll get you guys an update on all of that here in early December. But thank you guys both for being on the show, and any final word, anything you guys want to say that I might have missed on.
Yeah, no, I think, we appreciate you having us on, and look forward to continue working together with you guys.
Awesome. Thanks, everybody. Again, tune in, catch us on YouTube, Spotify, wherever it is you listen to your podcast, however it is you do that. Thanks.